All right, so let's continue here, and we're going to focus on identifying type 1 and type 2 errors. So for our type 1 error, we're going to use an example of a shepherd and a wolf. And let's say our null hypothesis is there is no wolf present. A type 1 error, or a false positive, would be crying wolf when there is no wolf present. Okay, that is the actual condition, was there was no wolf present. However, the shepherd wrongly indicated there was a wolf present by calling wolf wolf. Okay, so again, the actual condition was there was no wolf present, but the shepherd wrongly was calling wolf wolf. This is a type 1 error, or a false positive. All right, an example of a type 2 error, continuing with our shepherd and wolf example. Again, our null hypothesis is that there is no wolf present, and a type 2 error, or a false negative, would be doing nothing. Okay, so you're not crying wolf at all. Okay, so nothing's done when there is an actual wolf present. So the actual situation was there was a wolf present. However, the shepherd wrongly indicated there was no wolf present by doing nothing. And continued. Candy Crush for some of you are just mindlessly scrolling through TikTok while the wolf ate all of the sheep. Okay, so this is a type 2 error known as a false negative. So again, I want to tie those two things together. All right, so we have a type 1 error is what we call a false positive. And then our type 2 error is what we call a false negative. All right, so let's look at an example here. Number 7, so the USDA limit for salmonella contamination for ground beef is 7.5%. A meat inspector reports that ground beef produced by a company exceeds the USDA limit. You perform a hypothesis test to determine whether meat inspector's claim is true. When will a type 1 or type 2 error occur? Which error is more serious? All right, so when we go back and look, we see that salmonella contamination for ground beef is 7.5%, and that's the limit. And he is stating that the company exceeds the limit. So then we need to identify our null hypothesis and our alternative hypothesis. So our null, HO, is going to be P is less than or equal to 7.5%, or let's write it as a decimal, 0.075. And thus our alternative hypothesis is P is going to exceed, so it is strictly greater than that same thing, 0.075. All right, so let's look at a type 1 error. And so this will happen when the contaminant or contamination is less than the 7.5%, but we reject our null hypothesis. Okay, and then let's look at a type 2 error. In this case is when the contamination is greater than 7.5%, but we fail to reject our null hypothesis. And then the question we want to answer is, which error is more serious? Well, in this case, the one that is more serious is going to be our type 2 error, because what we now have is we have ground beef that has exceeded the contamination for salmonella that's going to make people sick, but we failed to catch it essentially because we failed to reject our null hypothesis, and therefore that ground beef is going to get sold to people and people are going to get sick from it. All right, let's look at another example here, number 8. All right, so I want you to read through that one, and similar to 7, I want you to come up with what is our null and alternative hypothesis, as well as when will a type 1 and type 2 error occur, and then which one is more serious. All right, so go and check your work and compare what you wrote for your null hypothesis and alternative hypothesis, also your reasoning for when a type 1 or type 2 error would occur. And to answer the second question, which one is more serious? Again, it's going to be a type 2 error, because now if that doesn't get caught, the parachute doesn't open, and that's going to be bad for whoever was hoping for that parachute to open. All right, so let's look at some definition here. So in a hypothesis test, the level of significance is your maximum allowable probability of making a type 1 error. It is denoted by alpha. All right, our lowercase Greek letter. And that's called the area and the tails. So at the extremes, right, of our, I think our normal distribution, our tails there. And the probability of a type 2 error, and the probability of a type 2 error is denoted by beta, which is the lowercase Greek letter beta. Okay, so by setting the level of significance at a small value, you're saying that you want the probability of rejecting a true null hypothesis to be small. And so our common used ones are alpha at 10%. This one's probably the biggest one we've talked about. Is it statistically significant previously? And we said at 5%. That's where this comes from. And then the extreme all the way down to 1%. All right, so the table here shows a relationship between our population parameters and their corresponding test statistic. So we have mu, our mean for the population, and x bar, our sample mean. And we had our talk about our z and test score, t-test. And then we have p and p hat, all right, for z, which we'll talk about also later. And this last one we won't quite get to in section 7.5, but you'll have a pretty good idea of what those can look like. All right, so a definition here. So if the null hypothesis is true, then a p-value or probability value of a hypothesis test is the probability of obtaining a sample statistic with a value as extreme or more extreme than one of the determined from the sample data. And there's 3 types we can do. So we can do a left-tailed, a right-tailed, and then a two-tailed, where it's going to be on both sides of our normal distribution graph. And the type of test we're going to do depends on the location of the region of our sampling distribution that favors a rejection of our null hypothesis. And this region is then defined or indicated by our alternative hypothesis, where that shows up at. Okay, so we'll look at what those will look like, and then in the next part we'll actually dive into how we test some of those things. All right, so the first one is a left-tailed test, and you can see, right, just as we looked up like in the z-table, that's the left side of the normal distribution. Okay, and then our alternative hypothesis contains less than inequality. And that's how we know we're going to be a left-tailed test. You can see that right there. Now on our right-tailed test, it's going to be on that side of our normal distribution. And the alternative hypothesis now contains a greater than inequality. And again, you can see that right there. And then last is a two-tailed test, or HA now is both sides, and it contains a not equal to symbol. And each tail, this is important, has an area of 1/2 of P. All right, so it gets split into the left and right of that. Okay, and so just kind of understand conceptually what these are and visually what they are. And the next part, we're going to dive in of actually how do we solve for these.